Hello, everybody. This is Community SIG Architecture community meeting for whatever the date is today, November 19th, 2020. And we've just got a couple items, and we got light attendance, probably because of KubeCon. So we'll see if we're able to handle these items. Swati, no, we did not hear you. Okay, so the first item was alternative platform discussions. I don't see Dim's here. I believe let's see, who asked me to put this on the agenda? Somebody asked me to put this on the agenda. I'm not sure what we wanted to talk about it on the agenda, because to me, we made some comments, and I think it needs some changes before it merges. As I mentioned here, and Derek, looks like you're on the same page there as far as this step 4 isn't really something that we need to put in here.
Yeah, so my concern on the PR was step 1 seemed burdensome and didn't have a clear tie to the release process, which was the basal requirement. Step 4 seemed outside the scope of needed success criteria, which was basically what I thought you captured as well. What was not clear to me, and I was hoping we could get an understanding of this call, is like, of the existing architectures, which met the proposed rules of the game. So I tried to reach out to some individuals. I saw Cindy commented around S390, but I wasn't sure for ARM or Power if we could get like a clear act on either what the missing steps were or that type of thing. So I just wasn't sure we had the right rallied set of folks yet on the PR.
Okay, well, it doesn't seem like we have the right folks on the call either. So it looks like recent comments, we'll see where that goes. I agree, I'm not sure that it's not clear to me why Basil would be strictly necessary, but not knowing the build and release process as well as maybe I should, you know, that, yeah, well, Basil's a whole other topic I don't want to necessarily get into. Okay, then looks like you made your comments, and we'll just go back to GitHub on this one, so we can move on from that. And then the only other item we have on the agenda here is this node resource topology. And the question, as I understand it, is around how to handle, well, one of the questions is around, we have an API, we want to create this API as a CRD for experimentation purposes, but there was a discussion, at least, that it was going to require something in KK to rely on that CRD for the scheduler plugin. It sounds like there's an option to do that scheduler plugin as an external, or do an external scheduler altogether. Where do we stand on this? And I know, Derek, you had some questions around whether the status of the CAP as well. Now that we're recording.
For those who weren't here, I guess before the recording, I had asked, are we getting ahead of the process, because the pod resource API kept merged and was, I would say, 70% implemented in 120. And that was a prereq to kind of do the other items that were discussed here. I wasn't aware of an actual KEP that had merged describing the API. And so I thought requesting the repo might have been getting ahead of the process a bit. But if we wanted to talk about the abstract on should the scheduler support out of tree plugins, or should these types of optional things get handled a certain way, I think we can. But I just want to make sure that like I wasn't missing something or forgetting something, that like there wasn't like a clear.
Yeah, can you hear me now, Derek?
Yes.
Okay. So we had in the CAP, we had 2 CAPs for topology-aware scheduling. In one of the CAPs, we had kind of explained that we would have this topology, node resource topology API. And initially, we had mentioned that we have this in NFD, But then when we had conversations with NFD maintainers, they said that it would lead to kind of circular dependencies because NFD imports Kubernetes, and then the scheduler plugin would need to import NFD, and eventually it will lead to circular dependencies. So the process. So we came to the conclusion that the only viable option for us is to place it in staging. So that's where the process of creating the staging repository started. Hearing from what you're saying, it seems that you're expecting another KEP to describe the topology API itself.
Right. Like I wouldn't have expected code to go into the core KK tree or KORG repo for the API without having a clear KEP describing it. And I think maybe earlier discussions had this treated as a kind of x-k-io like extended API and had some optionality. But I think given what the natural course of events you're describing around circular dependencies and stuff, that means like I would have expected at least a KEP describing the API, and then we could have the CRD or not CRD discussion. Maybe that's what Jordan you were trying to call out.
Okay, yeah, I think because we had this information captured as part of another KEP, we weren't sure that we needed like a separate KEP to do it. So it's kind of just a misunderstanding in terms of the process.
Yeah, I was having a hard time understanding. On the one hand, it sounded like this is like experimental, optional. We're not sure if it's gonna, proceed and graduate. Like we're just trying to get initial proof of concept and experimental stuff in. But on the other hand, it's wanting to merge like APIs into the core repo. And so I understand the circular dependency thing. I think that actually is sort of a gap in the scheduler. If the only way we can experiment with plugins is by introducing like in-tree APIs, that seems like a gap in the scheduler relative to all the other extension mechanisms we have. So rather than saying, well, I guess what we just have to do is merge everything in tree, like I know at one point we had the ability to run scheduler plugins out of tree. I'm not sure when we lost that ability.
I believe we still do. We still have the ability to run it as an out-of-tree scheduler plugin. But the reason we were trying to do it as an in-tree plugin is because Topology Manager itself has introduced a few gaps that is leading to topology unaware scheduling, and we were trying to address that. So that's the reason we wanted to propose it as an in-tree plugin. If it makes everyone more comfortable with like an out-of-tree scheduler plugin prior to having it in tree, we are okay to do that as well. I think I mentioned it as one of the options when we were speaking about the possible options of kind of moving ahead with this project.
Okay, I missed that was an option. I think just in terms of velocity, you would certainly be able to experiment a lot faster running it out of tree. Like in the time that it's taken to sort of work through the circular dependency stuff, and now that 120 is frozen, and I mean, just in terms of velocity, you'll be able to go way more quickly if you run something out of tree and say, run this scheduler and load this xk CRD and play with it and let us know. And then we can rev that rapidly. Once that's proven out, like once it's clear that it's widely used enough and proven out enough and performs well enough and all of those things to sort of justify being brought in as an in-tree thing, like that, I think that's a reasonable conversation to have. But I think it would benefit you in terms of velocity, and it would just make it a lot, there'd be a lot fewer people involved in the discussion if you just ran it out of tree and proved it out. So that's what we're asking a lot of people to do for like auth and policy stuff, like prove it out as a webhook, like the shape of the API.
I think concretely though, Jordan, right? We shouldn't have been creating the staging repo or the code PRs until the KEP merged. And I think that just because maybe a cap was open, we kind of have to do the merge step.
Yeah. So what I'm talking about is the whole, like, does this even belong in tree discussion? Like, assuming it did, either now or down the road, yes, there should be an implementable cap before we start merging code to support it.
I think the issue, though, that I'm hearing is that we've introduced with Topology Manager a situation where workloads are not scheduled, or they're scheduled to a node, but they can't actually run on the node because they violate the policy. So, and I guess Topology Manager is in tree, we're saying. So we're not offering an in-tree solution to a problem we created. Which, I mean, that may be fine because it's temporary, right? But I think it does make sense that if we've got something in tree that's causing this gap, we would eventually want to solve that in tree as well.
Yeah, I know Tim has been more involved in the topology stuff. What is Topology Manager alpha, beta? Where is it at?
So can I just to be clear here, topology here, can anybody hear me? Like my computer's all sorts of weird.
Yeah.
Topology here and the topology like zone region stuff are not the same, right? They're unfortunately saying more to the concept. Just for anybody who's sorry, my computer glitched and I lost the last like 2 minutes of conversation.
Yeah, so I think
my feeling on this.
Is it just me, or is Tim hard to understand?
Tim, your audio is terrible. We can't really hear you.
To maybe help.
I was not use the phone. Let me come back on the phone.
Yeah. So Topology Manager, the idea of the kubelet being able to align a device and a CPU and hopefully in the future memory to be on a common NUMA node, aka like the intranode topology. That feature is beta now. And so to your comment, John, on there's a way to configure the kubelet where the kubelet tries to align things, and a policy you can assign to the kubelet to align things that the cluster-wide scheduler may not be aware of is true. The impact of that is, and the ways to react to that are, there's a lot of ways to make that not a problem, I guess. But for the broader statement of like, would we want the scheduler to be aware of it or not? Like, that's the thing that I would just expect to have settled in the KEP. And personally, I have no objection to the in-tree scheduler being aware of what the kubelet was doing internally necessarily. But we just didn't have that clear KEP to point to that says it was merged. But absent that, I'd agree with Jordan that we can continue to innovate either out of tree with a custom scheduler or help the scheduler component today support the types of plugins needed.
So Derek, when you talk about a cap, like, do we need I think Swati mentioned a new cap. Do we need a new cap, or we just need to add to an existing? Is there an existing cap that this would fall under that can be enhanced to include this API? And then I guess Tim, if you have some things to say, you're welcome to jump in after that.
Yeah.
But Derek, you're more familiar with these caps. I don't even know.
Yeah. All I'm saying is I had tried to look into, prior to coming to today's meeting, was there a cap that clearly said this is the API, these are the fields on it, and this is where it should go, because some of the questions we're debating now I thought would have been debated in a cap, and I found two maybe open caps that we could consolidate, but neither of which had been merged. And some of the prerequisite building blocks that this feature said that they would depend on, did merge and are in process of getting added to features in the kubelet to facilitate it. But like, we're completely distinct from the question at hand on where this API is and how the scheduler becomes aware.
Yeah, one of the key part of the cap we're capturing in the cap is where we want this topology API to sit. Like at this stage, one of the caps says that it's going to be in staging. but it seemed like we need to have things in staging for the cap to get accepted. Maybe just kind of um, lack of knowledge on my part or our part in general to understand kind of the process. We had discussion in SIG node as well, explaining why we want this in staging, because like I explained that NFD would lead to circular dependencies. We also considered external repo, which would have similar issues. And then that left us just the only option of having it staging when we were just assuming that the scheduler plugin would be in tree. The out of tree discussions kind of started after that. So
the idea that we have a thing in tree to, I don't know, fix a problem or sort of complete a solution around topology would be stronger if the plan was for that to be enabled by default. But I thought that some of the comments were saying this would be an optional thing. Yes, we can hear you, Tim. I'm just talking over you. I'm sorry.
Okay. I want to express support for the idea here. Now, I'm going to assume that like the research project part of this is either been done or is being done to prove that such a thing is useful and efficacious. And given that, I feel like understanding topology at this level is a reasonable thing for Kubernetes to internalize and for the default scheduler to understand. And for on-node agents, whether that's Cubelet or something else, to help populate information about. So in general, I'm supportive of that. I don't know if all that homework has been done. And I don't know if the exploratory part of like, are there better options with respect to where the API should live? That's when I opened the discussion about topology API, I was looking at it purely from an API point of view. And as somebody who's got some background with the hardware side of NUMA, not from a, like, did you do the research point of view? Did you do the research?
Well, I would say from the proof of concept point of view, like in terms of how the topology should be exposed and having the end-to-end solution work, like exposing the CRDs and then the scheduler plugin using those CRDs to make the scheduling decision, we have it working. And like, is there anything else that you're trying to get to in this question?
Maybe just to make sure we're on the same, Tim. Obviously, the capability in the kubelet to align devices with their resources and their memory with their CPUs, that is working well, and people are successful with that today. And it had no impact to the end user API, right? It was a policy block.
Right.
The research here that had been presented was basically still having no end user impact to the pod API. But having an API to advertise back to the scheduler what the node's local scheduling decisions were. And the feedback loop on where and how to make that known is kind of the tension point here. And, but from like the earliest discussions that recall you and I had on this, like there is no impact to the end user pod API. This was all internal, finding the right communication vehicle between how the kubelet says what its concrete resource assignments were and making the scheduler then aware of that. And the prerequisite work for that was this pod resource API that advertised from the kubelet from a gRPC endpoint that says, these are the pods running, these are the CPUs that's assigned, and this is the devices it's consuming. That got done as a part of the GPU enablement work, and that was the building block that was being enriched in 120 in tree.
I also would like to mention about another source topology API. If you already took a look, it looks too generic. Initially, it was only about NUMA nodes, but now it could support a wide range of devices, wide range of different types. For example, hyperthreading, siblings, and so on. And internally, we have extension for CPU manager, which support hyperthreading, and current not resource topology API, which was in the PR. Current resource topology API could support it without any modification. So it generic enough for any user modifications.
So just was typing. The question I have is, do we have sufficient evidence that this level of integration is actually a good solution for whatever the important problem statements are? Like if we do all this work and it's a 1% improvement, that's not super exciting. But if we do all this work and it's a 90% improvement, then that's great. Do we have that data?
So are you saying that you're looking for performance numbers in this case?
I'm looking. So I'm not super close to SIG nodes day to day. I assume that there's a problem statement somewhere that we have decided is an important problem statement, and I'm
just so we can.
I'm looking for. Sorry, go ahead.
Yeah, I just wanted to focus the problem statement. So I do not believe the problem statement is I want my pod to be co-located with my CPU and memory and device as efficiently as possible. I don't think that problem statement is up for debate because that work has been done and is helping people today in Cube as it is today, running all sorts of workloads. The second order problem statement is I want to ensure that the scheduler schedules my pod to nodes whose policy will fit the desired semantics I wanted of alignment. I think from what I've seen in Swati and Alexi's work that it does minimize misscheduling problems. The impact of that misscheduling problem, of course, is how much users pre-plan their hardware deployment and the nature of slack capacity or utilization they're trying to achieve. But I do believe that the work results in better first attempt scheduling decisions.
I believe that. I guess I'm looking for a definition of like how do we know that this was successful? Is there a metric or some threshold of anecdotes or something that says like, yeah, this is actually worth the effort? And I guess to go back, Derek, to the question you asked before, like, is there a KEP that covers this overall?
Yeah, I just want to make sure we understood the problem statement was scheduling to a node that you can run, not performance, because performance is distinct from this.
Yeah.
What happens
if somebody
if we get scheduled to a node?
If somebody showed me.
Go ahead, Tim.
Sorry, I was going to say, if somebody could show me, look, we have $user who has these special requirements, and 25% of the time we schedule to a node that isn't at all feasible. And after this change, it's only 2% of the time. That would be wonderful. Like, am I asking for something unreasonable?
I think your question is the right question. I think the metric for value is important, and that is the question I would expect that this KEP would identify and answer, right? In a deployment of X nodes with this topology with a mixed workload, we see in our POC pods being scheduled at a rate of X rather than Y. That seems fine. But I think performance is completely distinct, and there are plenty of users taking advantage of what Cubelet has today.
If I may ask, what happens when a pod gets scheduled and it's not able to be? Does it get rescheduled somewhere else, and how long does that take?
So I just I just sent a link to you all. It's basically, it ends up in an error. It's topology affinity error. And if that pod is part of a deployment or a daemon set, it just keeps getting recreated on the same node because the scheduler essentially keeps making the same scheduling decision, and the pod just causes a series of runaway pods.
So just basically.
So that's a problem that we've sort of known about for a long time. Like, is that a problem worth solving on its own? Like, being able to thread two different pods together through I don't know, a nonce or something that the scheduler says, oh, hey, this thing failed on node X. I'm not going to put it on node X again. Like, that seems completely independent of NUMA or topology or anything else.
Yeah, it might be simpler, frankly, a solution.
Yeah, but the reason that happens is because the scheduler doesn't have the granular information of the resources available at a NUMA node level. And that's how we are trying to look at this problem and address this, by giving it the visibility and that information to make more topology-aware decisions.
Yeah, so Tim, I think the question is, do you want the pod to remain pending, or do you want the pod to loop around all nodes in your cluster in some type of cycle? But that's a complete piece of fair feedback. And from my experience, plenty of users pre-plan their workloads to their hardware for the scenarios where this is tackling, but not all. And so,
yeah, that's fair. I'm in the back of my mind, there's a voice that says there are going to be other reasons besides topology not fitting that you might want to say, don't run this pod on this node anymore. But there's just no way to express it, right? I don't mean to sidetrack and take this idea in a different direction. Like I said before, I am supportive of the idea of the understanding of topology. I just would like to know how to know that it was successful.
Sure, I think that is certainly a fair question. Maybe we need to do a bit more homework to have those metrics kind of laid out in front of you to show the benefit of this feature. Like we have the prototype working and everything working, and we know it works, but probably that's not enough to kind of take this forward.
Yeah, I mean, I would accept even as a result, like a model. We took the scheduler code, we built it into a program that had 5,000 virtual nodes with different topologies, and we threw what we think is a representative workload at the model, and this was the infeasible scheduling rate before the change, and here's the change. Here's the rate after this change, right?
Sure. Yep. Yeah, so we can work towards that. That's no problem, and we can bring those numbers back to you guys and then get more feedback.
And if it turns out it works and it's actually really effective, then I would be the first person to sign up to build it as an in-tree API, not as a third-party or external thing.
Okay, fair enough. Yeah.
Okay, do we have marching orders done? Everybody knows what they need to do? Any other questions? Otherwise, we're all done here, I think. All right, thank you. I mean, I guess I'll say one more thing, just because it keeps bugging me. Is I have to say I'm, it tickles me the wrong way that we are having to build in all kinds of node policy, like node topology policy information into the scheduler as well, and what next type of use cases are going to be for controlling what goes on a node and where, and then we have to build that into the scheduler too. I guess we have plugins for that, but it's not. I don't think it's nothing that rises. It's a level of coupling between the two that sort of it rubs me the wrong way, but I can understand the need for it, and there's going to be some of it. So
Yeah,
not enough for me.
I mean, we've been talking about topology literally since before 1.0, and like we've known forever that it would eventually be a thing that would hurt, and maybe it finally hurts enough for us to deal with it.
Yeah. So actually,
I guess we have like device manager to handle like and custom resource types to handle, and the scheduler already understands those. So that maybe handles most of the use cases, and we just needed something better for this topology.
Yeah, it's a little more complicated, John. Maybe so. Tim's right that we've been discussing this since before 1.0, and there were a lot of initial attempts to say make the pod spec actually like node topology aware and give preferences to a bunch of stuff. I would say that we've reached a place maybe a couple years into Cube's life where we said that the Cubelet was going to be responsible for making node local intra-node scheduling decisions and keep the scheduler opaque to it. And over the last, I don't know, 10 releases or so of Cube, we've evolved that, right? So the Cubelet got smart on picking CPUs, or the Cubelet got assigned devices, and then topology came up because you're like, well, I want my GPU next to my CPU. And so that we got to that point. And I think we've reached enough of a path where both components were able to evolve in ignorance of each other that this is the last thing that tries to bring it together. But I think we've come a long way from not needing the pod spec. To your comment on like dependencies between scheduler and Cubelet, we actually have a few that are somewhat frustrating because the Cubelet reruns the predicates before admitting the pod that the scheduler had followed. And so there are some other interesting situations that have come from that from a code dependency standpoint that, like, independent of topology, we have code sharing between Cubelet and scheduler that in the Cubelet submission control is not perfect yet either. So
okay, yeah. I mean, perfect's the enemy of the good, or good enough, right? So whatever that is, whatever the cliche is. Okay. Let's see what's Tim saying here.
Sorry, I'm just echoing what Derek said. I'd always been the person who said no to API changes until the Cubelet did the right thing automatically. And now that it mostly does the right thing automatically, I'm happy to start thinking about what API changes we need.
Perfect. All right. Thank you, everybody. Last chance for comments. Otherwise, we get back 20 minutes or so. All right. Thanks so much.
Thanks, everyone.